So my next question about polynomials is this. If we start off with a polynomial and we're asked to graph that polynomial, is point plotting enough? It was when we had lines, right? All we needed were 2 or 3 points and a ruler, and we were able to get the plot of that line very easily. What about polynomials with anything that's a degree 2 or higher? Well, we have a little bit of a problem. First of all, it might require a lot of points, and without more information, we might not know everything that we need to know in order to get a picture of that graph. For example, let's just consider y equals negative x squared plus 4x minus 2. Where do we start? Well, usually a good plan might be to start with x equals 0 and make up a table. So if we were to go through and let's make up a little table right here. Let's put our x values. I'm going to put my y values here. Give myself a little bit of room to do some calculation with. Let's say that we use y equals 0. Y equals 0. 0 squared minus 4 times 0 plus 2 is just going to give me 2. So I know that this is a graph that will pass through the point 0, 2. What else do I know? Well, I'm going to try a few other points. Let's try 1. 1, we're going to be getting, let's see if I'll just do this off the side, the negative of 1 squared plus 4 times 1 plus 2. I always like writing these things out because I always have to see it. So this is going to be like saying negative 1 plus 4 plus 2. So I know I'm going to get 6 minus 1. That's 5. Right? So I know that I'm going to get the point 1, 5. Let's see what happens at 2. Let's see what happens at 2. So in that case, we'd be taking the negative of 2 squared plus 4 times 2 plus 2. Let's see what happens here. Negative 2 squared, that's negative 4 plus 8 plus 2. And let's see, negative 4 plus 8 would be 6 plus 2, would be 4 plus 2, that would be 6. And so we would say 2, 6. Well, that looks kind of weird. Doesn't seem to follow any linear. Let's try one more. Let's try to see what happens with 3. 3. If we put in 3, we're going to get negative 9. I'm going to write this up here. Negative 9, right? 3 squared plus 4 times 3, so that's plus 12 plus 2. And then we're going to get negative 9 plus 12, which we know to be 3 plus 2. So now we're at 5. What is going on here? So let's check it out. I always like to plot this out. So let's see. What do we say? We said 0, 2. There it is. We said 1, 5. We said what do we say here? We said 2, 6. And then we said 3, 5. 3, 5 right here. So, well, that looks a little strange. I would have to get a few more points right here. I might have wanted to go on out to 4. Let me check that one out here and see what's going to happen. So 3, 5 we said was one of our points. What is going on with this pen here? So let's see. What if my pen doesn't like me anymore? Oh. All right. So 3, 5. Something odd is going on with all of this, but we'll see if we can fix it here in just a minute. I'll try that here. How about that? So let's say 3. That is weird. That should not be happening, huh? All right, pause for a minute here. Let me fix my pen. Okay, fix my pen there. I don't know what was happening with that malfunction there, but okay. So right now we found 3, 5. And then, of course, we said if we were to put in 4, what should happen? Well, it turns out that if we put in 4, we're going to get 2 again. So it looks like there's some strange kind of thing happening right here. And if I were to plot that out, 4, 2, right? Well, that is kind of what it's going to look like, I guess. Let's see if I can do this too. Nope. Let's see if this will work. There we go. If I plot 4, 2, there it is. Well, what does that look like? Let's see. Let's try it out. Right? Unless we had more information, we're not going to be able to necessarily figure out what that shape looks like, right? We might be able to connect it with some straight lines, but that's a curve, right? And one of the characteristics of polynomials is that they're always curved. Now, we could even see it more if we tried it out with this graph. And the problem that we're going to see is that we might get lots of little curves and bends. And how do we know where those occur? Sometimes that requires us to go through and try and do some different things. And let me see if I can plot this one in a different color as well here. Let's just try this out just briefly. And again, we'll just do some quick substitutions here. Let's see if we can do this in a different color. We'll try and do this in some quick substitution values here. Let's see. So x, y, and let's try the same trick. What if we said 0? Well, if we said 0, we're going to get 0. So we know this graph's going to pass through 0, 0. How about if we put in 1? Well, 1 to the third power minus 4 times 1 is the same thing as 1 minus 4. That's negative 3. That's kind of weird. Okay, maybe it goes down. Then we put in 2. So if we say 2 cubed minus 4 times 2, all of a sudden, well, we get 0 again. Odd. How about, let's try 3. 3 cubed. 3 cubed is 27. Minus 4 times 3, that's 12. 15. Oh, that's awfully odd. So if we were to go through and try to plot these points, now what are we going to say? Well, if we go through and do the same stuff that we've been doing all along here, trying to plot. Let's pick it out. It said 0, 0. Come on. Let's try 0, 0. Let's see. We said 1, negative 3. If we tried 2, be 0. If we said 3, 15, boy, we're way up there. Well, if we said negative 1, by the way, we're going to get positive 3 up here. I've tried this. If we try negative 2, we're going to get 0. And if we try negative 3, we're going to get negative 15. So now you might look at that and say, well, that is weird. Let's try it on this graph here. Well, what do you know? That's what it looks like, right? Unless we have more information from our polynomial, we're not really going to get enough by point plotting unless we pick a lot of points. And so in order to get more accurate graph, we need more information. In order to get that, we're going to have to go through a few things first. More in the next video.